Kirchhoff's current law. Enjoy. So to understand Kirchhoff's current law, we need to understand fundamentally Ohm's law. Ohm's law describes the relationship between voltage, current, and resistance. Fundamental understanding of this relationship is critical in understanding how current flows in more complex circuits. Kirchhoff's current law is fundamentally based on the conservation of charge, and that charge cannot be transformed or destroyed, but charge can only be transferred from one part of the system to another. Kirchhoff's current law is critical in understanding how current passes through a circuit. To first understand how current passes through a circuit, we must understand nodes. A node is where two or more wire or components split or merge within a circuit. The current going into a node must equal the current leaving the node. This is due to conservation of charge as previously mentioned. As you can see on the diagram, points B and D are nodes. Because as current enters B, it splits into a BD and BC. And then the BC and BD currents reconvene at D and go on back to the power source. Water through pipes serves as an incredible analogy on how current passes through circuits with components such as resistors. Simply, the larger the diameter of the pipe, the more water or current will flow. The more resistance, the opposite effect occurs. Less water will travel through. This ties us in to voltage divider rule. So voltage divider rule explains how current will distribute across a node. The less resistance in the branch, the more current will pass through that branch, and vice versa. If there's more resistance, less current will pass through that branch. However, we must remember the conservation of charge. So the current entering the node will always equal the sum of the currents of all the branches connected to it. So we'll verify this using voltage divider rule. So in the circuit, I'm just going to disregard the 2A current on the right there, just forget about that. So the total resistance is 6.714. We all know how to do that. Using V equals IR, that into B, the current is 1.489 amps. Using KCL's theory, what should happen is that the current of BC and BD will sum together to equal 1.489. We'll use voltage divider rule to calculate BC and BD. BC is 0.851 amps by using voltage divider rule, and BD is 0.638 using the same formula. And if we sub in B equals BC plus BD, they will be the same. And that is confirmation of